Okay, so we've discussed a little bit about how we're going to use the scene depth information to create an outline. So in this video, we're going to go ahead and set things up so we can start creating this effect. So we're going to start by creating a new material. So let's go ahead and go into our _game/materials folder. And I'm going to right click and create a new folder in here. And I'm going to call this post process. Double click that to open it, and we're going to create a new material. So right click and select material, and I'm going to call this material pp_highlight. Now pp stands for post process. Post processing effects are applied after everything else. So when rendering a scene, there are different passes in which the renderer goes through each of the buffers and uses the information in each buffer to alter the way the scene is rendered. Post-processing adds effects after all that. Let's go up here and stop showing the scene depth information by just going back to lit so we can see the regular scene. Now open up our PP highlight material. Now down here in the details panel, under material, we'll see material domain. By default, it's set to surface, and this is of course a material designated to be on the surface of objects. But if we click the drop down, there are different types of domains that this material can exist in, and one of them is post-process. Go ahead and click on that, and now we have a material designated for the post-process domain. Post-process materials apply to the entire world. So we now have a post-process material. Go ahead and save this and close it. Now here in the world outliner, I'm going to search for post, and you'll see that nothing pops up, which means there is no post-process volume in our world. Now we're going to add a post-process volume. So let's go up to the Place Actors tab and search for post, and you'll see this post-process volume. Go ahead and drag this in, and we get this little cube here in the world. This is a post-process volume. Now post-process materials can exist inside of post-process volumes. If there is a material in the volume and it's set for post-process, then you'll be able to see it. Now, the post-process volume only exists in the cube, but we can go over to the details panel for this post-process volume, and we can search for infinite, and you'll see this checkbox, infinite extent unbound. If you check that, then suddenly this post-process volume applies to the entire level. Now, if we have a post-process material, we'll be able to see it anywhere in our level. Now, post-process materials apply to the entire post-process volume. So if infinite extent is checked, then our post-process material will apply to the entire level. But that won't happen unless we add it to our post-process materials. Now, in our post-process volume details panel, we're going to search for rendering features. That's this section here, and in the rendering features section we have something called post-process materials. It's an array. Now right now it has 0 array elements, so as it stands currently our level will not have any post-process materials active, but we can add a post-process material to this array and it will suddenly apply to our world. Since we created PP highlight, which is a post-process material, we're going to go ahead and add it to our post-process volume post-process materials array. So click plus, and for the drop-down, we're going to select asset reference. Now there's a drop-down here that says none. If we click that, now we can select a material for this. Search for pp underscore, and here's pp highlight. Go ahead and select it, and now our pp highlight material is applied to the entire world. Now, as you can see, our PP highlight is simply black. So since we're using this post-process material, our entire world now appears black. Now, let's open PP highlight again, and notice we have an emissive color input to our PP highlight node. If we pass a single value into this node, it's taken to be grayscale. Now, here inside the materials editor, it's somewhat similar to the event graph in that we can create nodes. For example, we can create a scalar value or a single value constant by coming over here to the palette and finding constant and dragging it in. Now, next to constant, you'll see the number 1. That means you can hold down 1 and click, and you'll get the same thing. I'll go ahead and delete that one. Now we have this node for a constant, and it has a value of 0. If we drag that into emissive color, a value of 0 on grayscale corresponds to black. If we increase this value, then instead of black, we'll get a lighter color on the grayscale. 0.78, for example, is a little bit lighter gray, but not quite white. See? Let's go ahead and dock this at the top and then hit apply. If we hit apply in the materials editor, we'll take those changes that we've done and apply them to the material in the world. So now you can see that it's gray. Apply allows us to see what the material looks like without actually saving it. Now, instead of just a single number, we can also plug a color into emissive color. Hold down the 3 key and click with the left mouse button, and you'll now get a 3-component vector. And if you double click on it, you get a color picker. The 3 components of this are the red, green, and blue values. If you select a color, such as going up here to the blue, and then right here on the value ribbon, you can bring this from black all the way up, now we'll have a color that's blue. Click OK, and now we can plug that into emissive color. And now our PP highlight is a blue color. Click Apply, and now we can go into our world and see that our whole world is blue. So emissive color can take a single value or 3 values, and it will interpret that as a color. We can even use a constant 4 vector by holding 4 and clicking, or simply dragging one in. And a constant 4 vector has red, green, and blue values, and the 4th value is alpha. So if we select a color and click our value ribbon and bring that all the way up, then we can also select an alpha value, such as something in between 0 and 1, and then we have a color with an alpha. Now let's go ahead and delete all of these values. We can also plug other nodes into our emissive color. For example, we can get the color info for each pixel. If we right-click and type Scene Texture and get a Scene Texture node, then this node returns a color. Now the output color for this node returns the color for each pixel. Now we can't plug this into emissive color for this material because we'll get an error that says scene color lookups are only available when material domain is surface. Post-process materials should use the scene texture post-process input 0. So if this was not a post-process material and it was a surface material, then this would simply give us the color information. However, we can take this node, and in the details panel, we have something called Scene Texture ID. If we click this drop-down, we have a bunch of options, and one of them is Post-Process Input 0. If we select that, now we can plug color into emissive color. And this simply gives us the color of our scene. Go ahead and click Apply, and now you'll see our scene looks normal. So nodes like these return a color for every pixel in our scene. So it's kind of like a for loop. It's like we're looping through every single pixel in the scene and returning the color of that pixel. And then PP Highlight applies that to all the pixels on the screen. Now we can take this color information and we can tint it by multiplying by another color. For example, hold down the 3 key and left click, and let's go ahead and select a color on here, something like light blue. Remember to pull up our value on the value ribbon so it's not black. Go ahead and click OK. Now we can take the color returned from our scene texture node and multiply it by this color. However, the color returned from our post-process input 0 has RGBA values. In other words, it's a 4D vector. So what we can do is mask it by using a mask node. Type in mask and click on component mask, and this node will take our 4D vector and return a smaller vector. By default, it's the R and G, or the red and green values, but in the details panel, we can select the blue as well. So now we're taking our 4D vector, red, green, blue, and alpha, returned from the scene texture node, and we're taking only the red, green, and blue and returning a three-dimensional vector. Take the result of this, and we can type out multiply, and this gives us a multiply node. Let's take our new color and plug it into the B input, and the result of this multiply node is our color returned from the scene texture multiplied by our new color. So it's going to be tinted by this blue color. Plug this into emissive color and go ahead and click apply. You can see in the preview viewport that it looks tinted blue. And if we go back to our default map, we'll see that we get our scene tinted blue. So this is how post-process volumes and post-process materials work. They get applied to the entire scene. And the scene texture node set to post-process input 0 is how we can get the color information from our scene. And then everything we do after that is manipulating that color information and plugging it into emissive color for our post-process material, which will result in our scene being affected by our post-process material. So this is how we create and apply post-process materials, and this is what we're going to use for our outline effect. So we'll go ahead and conclude this video here, and we'll continue our study of post-process materials in our next video. I'll see you then.